Happy Monday, everyone. I am so sorry that I'm not there today. I know that I've missed a lot recently, and I apologize. Things have been a little bit crazy as we were finishing up our golf season. Um, just to let you know, on Thursday when we competed in the district, our girls finished third and moved into the regional tournament as a team. Our guys missed it by 2 strokes, though, but I did have 2 guys who did qualify for the regional tournament, and that is where I am today. So, again, sorry I'm not there, and I promise that my missing should be coming to a close as of today. So, anyways, I would like at this time for you guys to get out the homework that was named complex numbers. This is what you did on Thursday, and I asked you guys to do numbers 2 through 16 and include number 11. So basically, it was the right side of your page, including number 11. So I'm going to go through these with you since I'm not here. So hopefully you did this and you did it well. If you did not, I expect everyone to have this out on their desk and be checking it. And if you didn't do it, then I expect you to be doing it, writing it as we're doing it. So here we go. Number 2. You're supposed to take that first one, -6 plus 10i, and you're supposed to subtract 1 minus 2i. So what we said about this minus sign is it causes these signs to change. So that would become a -1, and that would become a plus 2i. So if I combine these vertically, -6 minus 1 is -7, and positive 10i plus 2i is positive 12i. So sure enough, the answer is -7 plus 12i. That is our complex solution. Okay, here you were supposed to distribute. So you're supposed to do -5i times -2. Well, that's positive 10i. And then you are also supposed to do -5i times -i. So negative times negative turn positive. 5 times an understood 1 is still just 5. And then you've got I times I, which is I squared. And that's one of the things we've talked about recently, that I squared has a value of -1. So this actually turns into positive 5 times -1, which is -5. So therefore, to put this in what we called standard form, we always started with our real part. So I'm going to put -5 first, and then that's a positive 10i, so I'm going to put plus 10i. So there's my answer, -5 plus 10i. All right, next one. We're supposed to distribute. -3 times 1 is -3. -3 times -2i, negative times negative is positive. 3 times 2 is 6. And no variable times I is I, so positive 6i. Then we're going to switch over here to -8i times 1. Well, -8i times 1 is -8i. That's pretty easy. And then -8i times -2i. So negative times negative is positive. 8 times 2 is 16. And I times I is I squared. Like we just said, and we're going to just keep this whole thing going, I squared equals -1. So that actually turns this into -16. So let's write this thing in standard form. You got your -3 minus 16. Those are our real parts. That's -19. And then you've got your positive 6i minus 8i. Well, that's -2i, so minus 2i. So -19 minus 2i. Okay, number 8, you had kind of a unique situation happen. So let's check it out. We're going to distribute. So 3 times 3, 9. Positive 3 times -5i. Okay, now be careful. Positive times negative is negative. And 3 times 5i is 15i. So -15i. Then we're going to switch. Positive 5i times 3 is the same thing. It's positive. And then finally, positive I, or 5i times -5i. Positive 5 times -5 is -25. And I times I is I squared, which we've been talking about. So that I squared is -1. So it's going to change that to plus 25, right? So look what happens right here in the, we got, first of all, 9 plus 25. which is 34. That's my real part. But what happens right here with my negative 15i plus 15i? Well, the signs are actually going to just cancel each other. So I have no more I terms remaining. It's just 34. Okay? So 34. There was no number 10. Number 11 and 12, I'm going to write them up here, just let you look at them. Your answers obviously will vary. Here's the key. On number 11, the word says commutative property. Commutative, we said, was all about the order. If you notice, the order changed. I had 3i in the front on the left side, but then I had 3i at the end on the right side. So the order changed. That's commutative property. Number 12 is associative property. And you notice I didn't change the order. I just changed the parentheses. I changed the grouping. See, when the order changes, commutative property. When the grouping changes, that is associative. So this is associative property. Okay, so that leads us to number 14. 14, we're solving a quadratic equation by taking the square root. If you notice, you have this squared here with this x, so I know it's quadratic, but there's no other x. So we can do this much like we've been doing recently, and we can isolate that x and we can solve. So here's how we start. We subtract 27. So 3 times x minus 4 squared will equal negative 27. Then we can divide by 3. So x minus 4 squared, oh, that's the worst squared ever, equals negative 9. Now here's the unique thing about this problem. Can I just get x alone right now? No, I first have to get rid of the square by taking the square root. Now hopefully you guys recall, what do we add to our answer because we took the square root? Plus or minus. Here's the new problem that we have here because we've learned complex numbers. How does that negative escape out of that radical? As an I. And then what about that 9? What is the square root of 9? 3. So it comes out and leaves me with plus or minus 3i. So the last step is to move that 4 over. And if you guys recall from the notes, when we move that over, we're adding it, right? Well, I can't add it to 3i. So what we do is we put it out front and we write our answer like this. Positive 4 plus or minus 3i. And that's as far as you can go with that particular problem. Okay? All right, so let's move to the bottom. And let's do number 16. It's the last one you guys had to do for homework. Subtract the 9. So 1/2 times x plus 6 squared equals negative 9. Then you had either one of two options. You could either divide by the 1/2. And since your calculator is good at dividing, that's fine. Or you could divide by or multiply by the reciprocal, which would have been 2/1 or 2. Either way, if you do it correctly, you're going to be left with x plus 6 squared equals negative 18. So next we're going to take the square root of both sides. So x plus 6 will equal plus or minus. How does that negative come out? As an I. But what about that 18? It's not a perfect square, so it doesn't just get to come all the way out like that other one did. So I want to find the biggest perfect square that does go into it though, and that is 9, and it goes in there twice. So this will break out as a 3, and that 2 stays stuck inside. So in this case, remember what we said the other day. We put the 3 in front of the I. We put the square root of 2 afterwards. So my answer when I subtract that 6 is negative 6 plus or minus 3i times the square root of 2. Okay? So that was your homework from the other night. Hopefully you guys did a good job on that and ready to move along. Okay? All right, so at this time you should be getting, or maybe you've already gotten, your note sheet for today that is dealing with what we're talking about, and that is called the quadratic formula. Before I get into this, because I will forget, I want to remind you all, please make sure that you're checking Synergy and that you're completing any missing assignment. I am trying to get all of these assignments up to date. That way you will know where you stand exactly. So if you would get on Synergy, look at what you're missing, and get those assignments in as quick as possible, that would be wonderful. If you're missing a quiz, or if you're missing a test or a portion of the test, please make sure that you make a point to come in during homeroom, either Tuesday, Wednesday, Thursday, or Friday. Well, actually, Friday, I don't think we have homeroom. But Friday, we will have an opportunity in class to make some things up. So, for you guys who are behind, Friday might be a great day for you to make up something that you're missing. All right, let's go ahead and get started on what we're doing today, and that is the quadratic formula. Now I want to remind you guys of the ways that you've solved so far. You solved by factoring. I don't know if you remember that. I think you do. You factored a problem, and then you took the factors and you set them equal to 0, and you solved. You also solved by graphing. Again, I don't know if you remember that, but we graphed it and we looked at the moment or the points where it crossed the x-axis. That's solving by factoring or by graphing. The other way that you've solved is by taking the square root. But if you guys recall, you can't always factor. You can't always see your solutions on the graph. Remember, what if it doesn't cross the x-axis? You can't see your solutions. You can't always solve by taking the square root. Remember, you can only do that when there's no x term. So the problem with the three methods that you've learned is that sometimes they don't work, right? So that's the problem. That is a problem, except for the fact that we have this thing called the quadratic formula. The reason the quadratic formula is so good is because it always works, always. There's never a time where it does not work for solving a quadratic equation. So that's why we wait and teach it dead last, because the other methods are probably easier and faster, and you won't make as many mistakes. But the problem is they don't always work. But the quadratic formula, it does. It always works, always. So here's the first stipulation. You've got to have your quadratic equation in standard form. It's got to be in the form ax squared plus bx plus c equals 0. That way you can clearly see your a, your b, and your c value. Please don't forget that the sign in front of it represents that value. All right, now next, we're going to go and plug these values directly in to the quadratic formula. Now, there's some songs on YouTube videos that you could look up quadratic formula songs. And again, they're kind of dumb and lame. I could sing it for you, but yeah, that's not going to happen. But anyways, here's the quadratic formula. You do not have to have this memorized by Thursday's test, but I would definitely recommend you memorize as quick as possible. The quadratic formula always works when you're solving for the equation, for the quadratic equation. Here's how it goes. Negative b plus or minus the square root of b squared minus 4ac, and all of it is divided by 2a. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. So here's how it actually works. First of all, let's look at this problem here. You've got to make sure that it's in standard form. Well, is this one in standard form? Absolutely it is. So what I recommend you do right off the bat is, something happened. There you go. I recommend that you label your A, B, and C value. So A is your x squared coefficient. What is it? Well, it's understood to be a 1. B is your x coefficient. So what is it? It's understood to be a 2. And C is your x, or your constant. So what is it? Negative 63. So we're going to take these values and we're going to plug them into this thing we call the quadratic formula. So here it is. X equals negative b plus or minus the square root of b squared minus 4 times a times c, and all of this is divided by 2 times a. So if you notice, all of the values that I just got them straight over here from my standard form of my quadratic, and I plugged them into the equation that I'm giving you. Now, the first thing I want you to do is I want you to simplify only the stuff that's under the radical. So when you go to your calculator, I don't want you to put the radical in it. Leave the radical alone for the time being, and just type in what's underneath it. So here we go. 2 squared minus 4 times 1 times negative 63. And that is 256. Now the reason I don't want you to go ahead and write the radical is because I want you to realize that sometimes it will be a perfect square, sometimes it won't. Sometimes it'll come right out of the radical, sometimes you'll have to break it down. So go ahead and just simplify the value that's inside the radical and leave it in there for the time being. And then on the bottom we've got 2. All right, so what is the square root of 256? Hopefully you guys recall. If not, type it in your calculator. The square root of 256 is 14. So if I were to type this or rewrite this, here's what I'm going to write. I'm sorry, it's 16. You're going to write negative 2 plus or minus 16 divided by 2. Notice how we don't have any more radicals. We can go ahead and simplify this. Well, remember there's 2 answers. One of them is negative 2 plus 16 divided by 2. And the other one is negative 2 minus 16 divided by 2. So here are my solutions. What is negative 2 plus 16? Well, that's 14. What's 14 divided by 2? 7. And the other one, what is negative 2 minus 16? That's negative 18. And what's negative 18 divided by 2? That's negative 9. So my 2 solutions are x equals 7 and x equals negative 9. All right, that is the quadratic formula. So let me just step back and I want you to see it. I know it's not appealing. I know it's not attractive. But the reason the quadratic formula is so good is because it always works. It always works. And that's why a lot of times people will just elect to go straight to the quadratic formula because they know it will get their answer. They don't stop to worry about whether it'll be factor or what it looks like in the graphing calculator or any of those things. They'll go straight to the quadratic formula because it always works. All right, so let's look at another couple of problems. I want you to see a specific thing. So let's go over here to number 4. And let's get everything on one side. Let's subtract 4x from 3x. And let's add that 15 to just out here alone. So here's what we got. We got negative 2x squared. What is 3x minus 4x? That's minus 1x. And then that plus 15. So first of all, let's label all of our values. What is a? Well, a is negative 2. What's b? b is negative 1. And what's c? What's my constant? It's positive 15. So here we go. Ready? X equals negative b plus or minus the square root of b squared minus 4 times a times c, and all of this is divided by 2 times a. So here's the key with this problem. When we simplify this stuff, first of all, what happens to minus a negative? It turns to just 1. Plus or minus. Leave the square root alone. And here's the key. You have to remember when this value of b is negative, you gotta put it in parentheses before you square it. So in your calculator, type in open parentheses, negative 1, close parentheses, squared, minus 4 times negative 2 times 15. And you get 121. Whoops. 121. And all of this is over 2 times negative 2, which is negative 4. So here's what we really have. We have 1 plus or minus, the square root of 121 is 11, divided by negative 4. So our answers are x equals, what is 1 plus 11? 12. What's 12 divided by negative 4? Negative 3. So there's one of my answers. And the other one is, what is 1 minus 11? Negative 10 divided by negative 4. That is 2.5. So my two solutions are x equals negative 3 and x equals 2.5. Okay, I hope you understand that. Not crazy hard, but it does have some challenges. Let me show you what happens on a problem like number 5. Look at number 5 with me. We're going to add, we're going to subtract that 24 to bring it over here. So negative 1 minus 24 is negative 25, and that equals 0. Now I know that you can look at this problem probably and notice that it's difference of squares, but remember, we're using the quadratic formula right now to solve these. So what's a? Well, remember, a is your x squared coefficient, so that's 9. What is b? B is usually my x coefficient, and there is no x, so we put a 0 there. And then finally, what's c? Well, that's your constant. That's your negative 25. So here we go. Let's see what happens when b is 0. X equals negative b plus or minus the square root of b squared minus 4 times a times c, and all of that is divided by 2 times a. So see here, negative 0, that's just 0, plus or minus the square root of, let's see what this equals. 0 squared minus 4 times 9 times negative 25 equals 900. Well, that's a pretty big number we haven't really talked about. So I encourage you just to check to see if it's a perfect square. On the bottom, 2 times 9 is 18. So go to your calculator real quick and type in the square root of 900. You get 30. So our answer is plus or minus 30 over 18. So what's that mean? Well, it means that one of my answers is positive 30 over 18. That's 5/3. And the other one is negative 30 over 18. So that's negative 5/3. So my two answers are positive and negative 5/3. So that's what happens when your b value is 0. You have that 0 plus out front. So your answer is just whatever those two values are, positive and negative, divided by your 2a. Okay, let's look at another unique problem, number 6. In this case, if I have 10x and move it over here, look at what I'm left with here. What's my a value? Well, my x squared coefficient is 8. What's my b value? Well, my x coefficient is negative 10. What's my c value? Well, I don't have a constant. So this time, my constant will be a 0. So let's see what happens here. X equals negative b plus or minus the square root of b squared minus 4 times a times c, and all of this is divided by 2 times a. Alright, so let's clean this up a little bit. What happens to minus negative 10? 10 plus or minus, leave the square root alone. Now let's go type in negative 10 in parentheses squared minus 4 times 8 times 0, and I get 100. And all of this is divided by 2 times 8, which is 16. So the 100, of course, is a perfect square, and it comes out as a 10. So we have 10 plus or minus 10 over 16. So let's see what our two answers are. What's 10 plus 10? 20. What's 20 divided by 16? 1.25. 1.25. And then what's the other answer? Well, what's 10 minus 10? 0. What's 0 divided by 16? 0. So my two answers are 1.25 and 0. Okay? Hopefully you guys are understanding this. We've done 4 of them. Let's do a couple more. Let's do number 10 and number 12. So first, number 10. Is everything on one side? No, we need to move that 8 over by subtracting it. So now let's name all of our values. A is -1, B is 10, and C is -8. So here we go. X equals -b plus or minus the square root of b squared minus 4 times a times c, and all of this is divided by 2 times a. So we've got -10 plus or minus the square root of, let's just reduce what's inside of here like I've told you I want you to do. 10 squared minus 4 times -1 times -8 gives me a 68. And all of this is divisible by -2. Well, 68, does that look like a number that you remember being a perfect square? Definitely not. So let's divide it by 2, 34. Don't try a perfect square above 34. So 68 divided by 25 won't work. 68 divided by 16 won't work. 68 divided by 9 won't work. So 68 divided by 4, we got to go all the way down to 4. And it's in there 17 times. So this 4 gets to break out as a 2, and that 17 remains inside. So here's what we got here. We got -10 plus or minus 2 square root of 17 divided by -2. So here's how we're going to simplify this. I want you guys to notice that denominator, -2, is 10 divisible by it? Yep. How about 2? Is it divisible by -2? Yes. So we're going to go ahead and reduce this, and here will be our final answer. Ready? What's -10 divided by -2? Well, that's a positive 5. Now look at this. I want you to see this, because this is kind of a tricky concept for some people. The next thing we're going to do is we're going to take this term and divide it by -2. I want you to notice the plus or minus. If I took plus or minus and divided it by a negative, I want you to notice what would happen. The positive divided by negative would turn negative. But then the negative divided by the negative would turn positive. So the plus or minus divided by negative would actually just turn to plus or minus. So you can kind of let that negative on the bottom be swallowed up by the plus or minus. And then you can just focus on the 2 divided by 2. What's 2 divided by 2? Well, that's 1 times the square root of 17. So this answer simplified is 5 plus or minus the square root of 17. That's kind of a tricky one. Hopefully you understand it. Okay, let's do one more right here. We're going to subtract the 4x really from nothing, because it doesn't have anywhere to go. We're going to subtract this 5 from the 9. So let's see what that leaves us with. It leaves us with 5x squared minus 4x minus or plus 4, because that's what 9 minus 5 equals. So here we go. Our a value is 5. Hopefully you saw that. B is -4. C is +4. So here we go. X equals -b plus or minus the square root of, b is negative, so in parentheses, b squared minus 4 times a times c, and all of that is divided by 2 times a. So let's do some cleanup. What happens to -4? 4 plus or minus. Leave the square root alone, and let's just type in what's underneath it. That's open parentheses negative 4, close parentheses squared, minus 4 times 5 times 4, and that equals negative 64. And all of that is divided by 10, 2 times 5. So look what happens here with this problem. This is kind of similar to what we've done recently. That right there, 4 plus or minus, equals, or I'm sorry, the square root of negative 64, how does that negative escape that radical? As an I, remember that? And then what about that square root of 64? Does it escape? Yeah, it escapes as an 8. So 4 plus or minus 8i over 10. Now, if you wrote that answer, I would probably not mark it wrong. But I do want you to notice something. Do you notice how every one of these terms are all divisible by 2? Because every one of these terms are divisible by 2, in a book, here's what it would do. Or like on a test, like an ACT, here's what it would do. It would divide each of those by 2. What would 4 divided by 2 equal? 2 plus or minus. What would 8 divided by 2 equal? 4i divided by, what's 10 divided by 2? 5. So on a ACT test or EOC test or something, this is how they would have it, as 2 plus or minus 4i divided by 5. Or you might see them separate it and put it like this: 2 over 5 plus or minus 4 over 5i. All they did there was they just took this one and this one and divided them and just left them separate. So anyways, that is how you solve using the quadratic formula. Now again, I know you look through these and you're like, man, that's kind of confusing, and it can be. Okay, I didn't say that quadratic formula is the most appealing looking one. I just said that the reason people love quadratic formula is because it always works. There's never a time that you're trying to solve a quadratic equation and it won't work. So here's your homework for tonight. It should be passed out by now, or it might be heading your way. But the worksheet says the quadratic formula, homework number 7, and I want you to do the evens down the right side. Numbers 2, 4, 6, 8, 10, and 12. So the right side, that's 6 problems that I want you to do tonight for homework. Again, I'll be back tomorrow. Unless something else happens, I don't think it will. So we'll see you tomorrow. Hope you guys do well with the quadratic formula. Give it your best effort, and we'll see you tomorrow.